The dimensions that you develop are attribute-based. Dimension attributes correspond to the columns in your dimension tables, and by default, each attribute will produce a hierarchy, albeit a very shallow hierarchy that by default has an all level, and then it has a single level containing the values of that attribute. These are often referred to as attribute hierarchies, and they will contrast from another hierarchy that we'll just introduce in short time. They have that all level and the members found in the key columns, and I'll introduce this property in a moment. Now, these attributes can be organized into user-defined hierarchies, which are then referred to typically as multi-level hierarchies to contrast with the shallow nature of an attribute hierarchy. Let's then define what hierarchies are. They provide navigational paths, and they provide several benefits in a cube design to your browsers. They enable viewing data at different levels of summarization. Let's consider then a calendar hierarchy that allows navigation from a year level to a quarter, down to a month, and then date level. Users can then choose the summarization that they need. They provide paths to then drill down and then drill back up again. And they encourage the user to navigate to a smaller subset of the data. The useful attribute properties then. The name of the attribute. There's the usage, whether it's set to key, parent, or regular. There must be at least one key attribute within the dimension. And when we talk about the key columns property in a moment, the key column for the key attribute is always the primary key of your dimension table. This becomes the very root of the dimension structure. The other type is parent, and you may only have one parent usage of an attribute, and this attribute would then generate a parent-child hierarchy. What that means is that all remaining attributes in your dimension will be set to regular. Now, the important property when connecting to the source column. The key columns, and note that this property name is plural. This will set the bindings to the columns containing the member keys. Now, remember, for the key attribute within your dimension, the key column should always be set to the primary key. Now, what this means is that when it generates the membership of the attribute hierarchy, it uses a select distinct query based on the key columns. So a select distinct on a primary key, the primary key being unique, will guarantee that the key attribute provides a member for each row within the dimension table. Key columns being plural implies that you may have multiple columns here. Therefore, the combination of distinct values found in those columns would generate the membership of the hierarchy. Generally, I would recommend that while you can have multiple columns, you should restrict it to a single column, even if this means preparing your data in the data source view or the data source to ensure that you have a single unique key for the attribute that you're configuring. The next property is the name column, and it allows you to determine what the caption is for the member name that the users will see when browsing the hierarchy. Now, this can be left unset if your key columns uses a single column, in which case that column will also be used to deliver the name of your member. If you have multiple key columns, then you must specify a single name column that will be used to define the name of the members of your hierarchy. Next, we have the type for the attribute itself. And we saw earlier in the previous topic that dimensions have a type, and attributes also have a type, allowing you to define the nature of the data that they present. The attribute hierarchy visible property, when set to true, will ensure that client tools will see the hierarchy, but when set to false, will not be then delivered for use in reporting tools. The attribute hierarchy enabled, when set to true, will ensure that the hierarchy is created, and when set to false, it will not generate a hierarchy, which will result in the attribute being available as a member property. Now, imagine that we have an attribute in our customer dimension, which is the phone number. The consideration is, would we ever need to group by or filter on phone number? And you'd probably decide that that's an unlikely, business-related query. But phone number is important to supplement the reports that we write based on customers. So we can continue to include the attribute, but by disabling the hierarchy, we may only use it as a member property, not as a hierarchy for filtering or grouping. Lastly, in the list, we have attribute hierarchy display folder. And display folders allow you to organize the content within a single dimension. Let's imagine that some dimensions might have lots of attributes and hierarchies, and so therefore, in a client tool, it might be easier to group them together within display folders. Continuing, we also have a default member property. And so this allows you at attribute level to determine what a default member would be. That default member is often not set. And you need to be careful here that by setting a default member, it will be used by default whether the user understands it or not. For example, if I set the country attribute within my customer dimension to default to Australia, people writing reports would simply see Australian data without appreciating that that automatic filter is in place. So while we can configure default members, the usual practice is not to. What that means is the default member will be the first in the hierarchy, which almost always is the all member of the hierarchy. That delivers a very natural experience. By filtering on the all member, we get by default all colors, all countries, all products. The isAggregable property, when set to true, ensures that you will have that all level on the attribute hierarchy. When set to false, you will no longer have that all level. And it's only in specific circumstances, from my experience, that we need to turn the all level off. And that essentially comes down to whether the members of the attribute are additive. Now, for example, if I have in my finance cube, I have a scenario dimension. Are we viewing financial metrics for actual or for budget or for forecast? We should only ever filter on one at a time, and certainly we should not aggregate across those scenarios. There's an example where I would set the isAggregatable property to false. And as a result, I would be inclined to review the default member property to set it to a default that might be the most common set member for that hierarchy. We next have the orderBy property, and this allows you to control the order of the members within the attribute hierarchy. It can be set to name, key, attribute name, or attribute key. And sometimes it makes sense to sort by name, or it might be the key value itself that would provide a better sort order. Now, when configuring attribute name and attribute key, it requires that you have attribute relationships correctly configured, and that will be the topic of the next video. So the attribute by or order by attribute property would allow you then to select which attribute are we sorting by. The custom rollup column, so this is for advanced rollup custom aggregation. So we'll talk about aggregation when configuring measures in the next lesson, but there is the ability within an attribute hierarchy itself to use MD expressions in source data that can provide fine-grained control on exactly how values should aggregate up through the hierarchy. A little more on those display folders. So those display folders help you organize model resources. So they do include dimension attributes and also the hierarchies in your dimension. As you'll learn when developing cubes, measures can also be assigned to folders, as can calculations, KPIs. Now, the folders are contained within dimensions and measure groups, and they can be nested within folders. So let's have the conversation now. It's possible to display a single resource in multiple folders. And you can create subfolders that produce a folder path by using the / character. For example, folder within it, we have subfolder within it, we have subfolder 2. To assign a resource to more than one folder, you separate folder paths by using the semicolon character. User-defined hierarchies is the next topic. Having defined attribute hierarchies as being shallow in nature, user-defined hierarchies being assembled from dimension attributes give us multi-level hierarchies. So these represent navigational paths across the dimension attributes. We create when relationships exist between attributes, and they can be configured as ragged, and they can also be configured as natural or unnatural. And members of natural hierarchies only ever have one parent member, and so attribute relationships should reflect this. This is an important topic, and we're going to cover it in the next topic. Let's then take a look at what I mean by a ragged hierarchy. Let's start by understanding what a non-ragged hierarchy is. So here is from my date dimension, a hierarchy giving me the calendar year 2017. We can see a level beneath it providing me 2 members for Q1 and Q2, and then the third level providing me the months within the quarters. So as a non-ragged hierarchy, we have consistency in depth, that every member has the same number of parents for those members on the same level. Talking of levels, at the year level, we have 2017. At the quarter level, we have Q1 and Q2, and then at the month level, we have those 6 months. Now, in contrast, a ragged hierarchy has a variable number of levels. Let's see an example here that shows that we have the all level at top, and then we have country followed by state, and then followed by city. And what we can see here is that New Zealand, being a smaller country, doesn't have the concept of states. And so in a sense, it sort of skips down to the city level. And so we can see that the cities of Auckland and Wellington have 2 ancestors as opposed to the cities in Australia that have 3 ancestors within the hierarchy. Useful hierarchy properties. Each hierarchy in the dimension must be uniquely named. The all member name property can allow you to override the default name for the all member to something that suits your design. The allow duplicate names property, when set to true, allows members with a common parent to have the same name. And the display folder allows you to categorize this hierarchy into a folder of the dimension. Now, there are hierarchy level properties also. So each name of the hierarchy must have a unique name. There's the source attribute upon which it is based. And there's also the hide member if, which allows you to generate the ragged hierarchy. It can be set to never, or the only child with no name, only child with parent name, no name, or parent name. So imagine in the example that I gave with New Zealand, in the dimension table, we would still have a state column, but we could set the state name to New Zealand. And therefore, I could configure that hierarchy to use the hide member if it is the only child with parent name.